Hello everybody and welcome to video 1 for the cumulative review packet number 11. To start the packet, we are going to be doing what we've been doing the most recently, which is solving quadratics either by completing the square, quadratic formula, or factoring. So for the first one, we want to solve by completing the square, and here is why. Notice that we have a lead number of 1, and that usually points to either factoring or completing the square. And also notice that our b term is even. So whenever we have an even b term, that's when completing the square is useful as well. It is always a good idea to see if you can factor something first. So if I did try to factor this and think about what two numbers multiply to be 20 and add to be -4, I don't think we could find a pair. 1 and 20, 2 and 10, 4 and 5. None of these can combine to be -4, which is why factoring does not work, which is why I asked to do completing the square here. So in order to complete the square, we cannot be equal to 0. So the first thing I'm going to do is add the 20 to both sides. You get x squared minus 4x equals 20. Now I want to add that special number on both sides, which is b over 2 squared. My b term is -4. So -4 divided by 2 is -2. -2 squared is +4. Which means over here, I would now have x squared minus 4x plus the special number of 4 equals 20 plus the special number of 4 again. So what we want to do is now simplify on both sides. On this side, we just want to add 20 and 4 to get 24. On this side, we want parentheses so that we can eventually take the square root. In order to do that, I notice that this side factors. Specifically, it factors into x minus 2, because -2 times -2 is +4, and -2 plus -2 is -4. This now can be written as x minus 2 quantity squared equals 24. So now I can take the square root of both sides. Squaring and square rooting are inverse operations, so they cancel, and I'm left with x minus 2 equals 2 answers because it's quadratic, so plus or minus the square root of 24. So now if I want to get x alone, I need to add the 2 on both sides. So I'd have x equals 2 plus or minus square root of 24. Now, if we look at 24, it is not a perfect square, but it is something that could be split into two radicals. So we have x equals 2 plus or minus. If I split 24, I think about my perfect square list, 1, 4, 9, 16, 25, and so on. And 4 definitely multiplies into 24, 4 times 6 specifically. So now I can take the square root of 4 and reduce that to just 2. So my answer would be x equals 2 plus or minus 2 root 6. So over here, my exact roots would be 2 plus or minus 2 root 6. And yes, you could write that as 2 plus 2 root 6. And 2 minus 2 root 6, if you prefer. Now, if you want to find the decimal answers, you need to type this into your calculator and then separately this into your calculator. Remember, with the graphing calculators, you have to press second and then x squared in order to get the square root. Now, because I'm on my computer, I'm going to go ahead and use Desmos to find the decimals. So if I bring that up and type in 2 plus, sorry about this box, 2 root 6. Looks like one of my answers over here is 6.89, which is about 6.90 if we're going to round that. So one of my answers is 6.90. And then if I go back to Desmos here, and then instead of plus, I have minus, it looks like I have -2.90 about. So if we go back here, -2.90. Those would be my two answers as decimals. Number 2, solve the equation by using the quadratic formula. And again, round your answers to the nearest hundredth when we get there. So if I looked at this problem, I could try to factor with splitting the middle term, but instead I'm going to try to use the quadratic formula, because if I even tried to divide everything by 2, I would get an odd middle term, which does not lead to completing the square. So instead, let me use the quadratic formula. So I'm going to write it here generally first. And in this case, the A term is 2, the B term is negative 10, and the C term is 5. I like the way this is formatted because in order to use the quadratic formula, it needs to be equal to 0, unlike completing the square. So now if I plug in what I know, I have x equals negative b plus or minus the square root of b squared minus 4 times 2 times 5 all over 2 times a, which is 2. If I keep simplifying, the two negatives here become a plus, so x equals positive 10 plus or minus the square root. Negative 10 squared is positive 100. If I look at these three numbers, I notice that I only see one negative, which means that the negative carries down here. If I saw two negatives, that would be a plus. If I multiply 4 times 2 times 5, that's 8 times 5, or 40, all over 4. So x equals 10 plus or minus the square root of 60 all over 4. As we talked about in class, these are not like terms because the 60 is under a square root, so we can't take a 2 or anything out yet until I take 60 and I split it into two radicals. Now, again, if I think about my perfect square list here, I think about what is divisible into 60, and again, it might be 4 that's my winner. 4 times 15 is 60. And just to double check that, let me just go through. Yep, 60. So what I can do is now reduce the 4 again to be 2 root 15 all over 4. Now that I have this triangle of like terms, like in class, we can divide everything by 2. So my final answer for exact roots would be x equals 5 plus or minus 1 root 15 over 2. Well, we don't necessarily need that 1 there because we're multiplying. So a good way to write it would be x equals 5 plus or minus the square root of 15 all over 2. So now if I wanted to find my decimal answers, remember this is really two answers. 5 plus the square root of 15 all divided by 2, and 5 minus the square root of 15 all divided by 2. So if you were going to plug this in your calculator, what I would do is do the 5 plus root 15 first, then I would press enter, and then I would just then divide by 2. And then I would do 5 minus root 15, press enter, and then divide by 2. So I'm going to pause the video here for a second, and I'm going to do the answers via my calculator because the online thing isn't working that well right now. So I will be back with the answers in a little bit, so give me just a second. Okay, here are my two answers in purple. From this first one, I got 4.44, and from the second one, I got 0.56. So feel free to please check those in your own calculator. Number 3, solve the equation by factoring. In order to factor, we need it equal to 0. So the first thing I'm going to do is subtract the 40 over to the other side and get 4x squared minus 12x minus 40 equals 0. I then notice that I have a greatest common factor of 4, but because it's an equation, I could divide everything by 4 to make my life easier. When I do that, I get x squared minus 3x minus 10 equals 0. And I could try to do this with the quadratic formula. I could try with completing the square, but I notice that this one does factor. The two numbers that multiply to be negative 10 and add to be negative 3 would be 5 and 2, specifically negative 5 plus 2. So I would have x minus 5, x plus 2 equals 0. When I set both parentheses now equal to 0, my two answers would be x equals negative 2 and x equals positive 5. No decimals this time because my answers are nice. Now looking at numbers 4 and 5, it says solve the equation, specifically the quadratics, using the method of your choice. So because they have x squareds, we could use quadratic formula, completing the square, or factoring. And it's always a good idea to check factoring first. So for instance, if I looked at number 4, I noticed that I have a lead number or lead coefficient of 2. Everything is divisible by 2. So if I get rid of the 2, I get x squared minus 6x equals negative 16. And let's check, I'm just going to write a little note, does this factor? Can I save myself time? So if I move the 16 over and get this, I want to see if this is possible. So two numbers that multiply to be positive 16 and add to be negative 6. Well, if I think of my options for 16, I have 1 and 2, 16, 2 and 8, and 4 and 4. My eye goes to 2 and 8, but if I want to get negative 6, that have to be 2 minus 8, and 2 times negative 8 is not a positive 16. So unfortunately, no, this one cannot factor. So I'm going to put a big old no, it cannot. So when something can't factor, I have to decide between completing the square and quadratic formula. Because I have a lead number of 1 and I have an even b term, I'm going to go ahead and complete the square. So to do that, I need that special number on both sides. So if I take the b of negative 6, divide it by 2 and square it, that would be negative 3 squared, or 9. So I would add the 9 on both sides of my equation. So if I simplify over here, I would get negative 7. And if I simplify over here, if I tried to factor this, I would get x minus 3, which could be written as x minus 3 squared. So written more neatly, I have x minus 3 squared equals negative 7. But now we run into a little bit of an issue. When I take the square root of both sides, these do cancel, and I get x minus 3 equals plus or minus the square root of negative 7. A lot of you may remember from class that as soon as you have a negative underneath the square root, there's no way that you can get a number times itself to be negative. So because I see this is not possible, so my answer is no solution, or you could just write it as the no solution symbol. So there's really no solutions or no real solutions. If I take a look at number 5 here, my goal is to solve it, any of the three methods. I notice that it's equal to 0, so I'm tempted just to check to see if it factors. And to remind you of something from our last cumulative test, please notice that the a and c term are both perfect squares. So when I had perfect squares on the ends, I was likely to be able to factor it. So let's see if we can factor this time. If I try to split into two parentheses, what times what gives me 9x squared? 3x times 3x. What times what gives me 4? 2 and 2. So can I get this 6 and this 6 to become a negative 12? Yes, I can. If I think about 6 and 6, if both of them are negative, then they become a negative 12. So I'd have a minus and a minus. So if I wanted to solve this, I would have to set 3x minus 2 equal to 0 2 times. Now, this is the same parenthesis twice, which means that I only really have one answer. If I add 2 to the other side, I get 3x equals 2, divide by 3, so x is a positive 2/3, which is the same answer that I would get here. So yay, factoring worked, but again, you could have used quadratic formula or completing the square. Probably would have given you the same answer. Okay, for number 6, the goal is to write a quadratic equation. So I want to write something that is in the form x squared. That's what I want in the end. Now what it says, but what it means by that the roots are 4 and negative 7 is that you already got the answers of x equals positive 4 and x equals negative 7. So if I look back for a minute at number 3, for instance, notice that I already had my answers or my roots down here. So my goal is to get from these to the parentheses and then to get something that looks like this in standard form. So notice here that if I have a positive 5 as an answer, that came from x minus 5. And if I have negative 2 as an answer, that came from x plus 2. So if I looked at this one, if my answer was x equals 4, that came from x minus 4. And if my answer was x minus 7, that came from x plus 7. So I'm going to continue this problem on the next video. We just don't have time now. So please join me on video 2. Thanks.